All right, we're back. So at this point, we were successfully able to put the uppercase letter H on the screen. Unfortunately, our intention was the entire text of Hello World. In addition, if we look here, pixel static 16, we have the top value and a left value for positioning, and we got somewhere to the left if you look here, but it is definitely right up against that top edge. So we're not positioned where we want, and we don't have all the letters that we want. I think we're going to focus on the positioning first, and depending on how long that takes, we may break the multiple letters into another session. All right, so here's our code, and so font, frame buffer, top left. So I'm going to come in here, top, then left. So we should be 32 lines from the top. And if we look here, we are 320 lines wide, 240 lines tall. So our top value should be 32 times 320. And so that is 10,240. And our left value here is only 16. And that so if we think about it, we need to be over to the left, maybe a little bit more, maybe not much. Yeah, that would be the third letter, so that's about right. So, but once again in pixels, it's going to be that plus that. So by calculating those values, we can check the calculations that occur in the code. And so we come over to the code, and this is a pretty long little block of code, and we can see that it's a bit hard to read, just like our other one. So we're going to start it off, and we're going to do the same scope concept on this function. And again, the goal is just to make this a little bit easier to read and maintain, if you will. So at the top, we had all of this error checking, which is really nice, but all right, so I just want to point out why this scope keyword matters, and that is we have this label of exit, and we can see that it's actually used in this other function, and so it's already defined there technically, but in essence we actually defined it again here, and so we just want to see that that compiles. And that will tell us that our scope keyword is working like we think. And there we go. So because it's inside the curly braces, now if I take this same value and do it there, that will fail. Because constant cannot be modified. which is exactly what we expect. So that was good. All right, so yeah, lots of this. Lots of this. A1, 3V1. All right. So font address A0 FB is A1 and I usually like a longer, more descriptive variable name, but I'm surprised at how much easier it is to read with a short one in assembly language. Now this one is a little bit interesting because it's actually made up of these two values, because we needed to pass in more more data than our 4 argument registers would allow. So we actually used 2 techniques here. This is just a reminder. You can see this all in a previous video. String label A3. Now this one I'm going to have a variable because it'll be nice to be able to increment through this string 1 character at a time, whereas these other values will not be changing. And so oh, and actually this is another constant. String length v1. Okay, and I'm just going to put in a comment here. Parameter validation. All right, so I think that kind of cleaned up nice. All right, and I'm actually going to move that there so that it stands out a little bit more, a little more obvious that it's a variable, doesn't get shuffled in with the constants. Sequence-wise, it's a little out of sequence, but not as bad as you'd think. The V register's weird, so I think that'll be good. So just kind of the refresher. The first thing that we do is we take our string label and read a value. All right. So here's A0, that's our font address. And A1 is our frame buffer. And V1 is our length. And the other thing, just a quick reminder, thinking it for myself as well, this position value, even though it's technically two 16-bit values, it could legitimately be 0. And so we're just going to let that one go. Whatever they give us, we're going to trust it. All right. So I'm going to create a variable of current car and call that T0. And then take this and use it all over the place here. Okay. All right, so here we have our ASCII character, and we have to subtract 32 from it because our font does not have the non-printable characters that are below 32. So let's make that a constant. Oops. First printable ASCII 32. Okay. All right, so then we got some kind of reminders about the math that's going on here. So we have 128 bytes per character, so that's another value here, constant. Bytes per car, 128. All right. Yeah, this gets really hard to read. So that line is good. T1. Okay, so that's the constant. So T1 is our countdown. So this is a variable, and this is remaining bytes for car T1. It was a little long, but again, we're going to move these up and kind of keep them clear. All right, so that's managing our bytes per character. This is our multiply, and we're kind of doing a couple of things with this. So that gets our first printable character. We're not really dealing with our position yet. That's this little bit of code here. Alright, so this is our code to parse out our parameters. And this I think I moved it down as an optimization, and I'm kind of undoing that because right now I need the code to be clear. So kind of sucks to undo the work that I was doing, but it's the right thing to do here. Alright, so here is our position. So A2, we're going to do this. Alright, so variable T2, so SRL is to shift right logical. So it's going to take the value in A2, or the position, shift it to the right 16, and put the result into T2. So this was the high 16 bits, which is the top. So we're going to create top and call that T2. And that is still position, but I actually want to call that left. So once again, we would like to be able to do that, but I kind of want to see if the assembler complains. No, we're in the good. And I think that's because it's really just treating A2 as whatever the register number is. It's not seeing it as, oh, I've already used that A2 up here. So we're in the clear, and now I have a left that is the same, but a more intuitive name. So that's good. And here I'm kind of showing the code that's happening. If I say top position, and this is left equals position, yeah, I don't know, but it's really something we're only doing once, I believe. So we'll come back and see if we need to do something different at all. All right, so here's where we get our current character, our ASCII, and this is we're initializing this variable for each character. Yeah, we're going to end up rewriting all of this. Bummer. Okay. But we should be able to maintain it once we're done. That's the goal. That is the goal. Alright, so at this point, I've set up all of those characters. I really want to start calculating doing the math here. 32 times 320. And okay. Oh. Messy, messy, messy. Calculate top memory address and calculate left memory address. Alright, this session's running a lot longer than I was expecting, and I got a late start, so let's see if it works at all. I don't like to leave it in a broken state. Alright, we get our H. We're still in that same position. Alright. I regret, but I am going to stop now. I'm getting tired, and thank everybody for your time watching, and I will get back to this very soon. Thanks.